So let's say that you discover a piece of data that in Washington State, the average Uber driver rating is actually higher than the average Lyft driver rating. And the same thing happens when you look at the state data for Oregon. But when you combine the data from the two states, you actually realize that the average driver rating for the combined Washington-Oregon states is higher for Lyft than it is for Uber. How is this possible? How can this be?
Okay, so this is like a brain teaser. Um, so just to reiterate the question, um, you said that it's a situation where the Uber rating is higher than the Lyft ratings in both Washington and Oregon. However, if we look at all of the data, we find that Lyft ratings are higher than Uber ratings.
Yeah, that is correct.
Mm-hmm. Okay. So for a problem like this, sometimes I find it's a little bit easier to think in terms of concrete numbers, so it's a little bit less abstract. So I'm going to go and jot down some notes and kind of talk through as I go along. So, I mean, in this situation, we have our two states, Washington and Oregon. And so I just made those into columns, and then we have Uber and Lyft as our rows. So we could have a situation where the average Uber rating in Washington is 4.9, and the average Lyft rating is 4.8. And Oregon, similarly, it could be 4.6 Uber and 4.5 Oregon. Just looking at this, it's a little bit odd because we would expect the service that wins in both states to be the one that wins when we look at all of this data all together. So let's kind of just break this a little bit more, and instead of thinking about numbers in terms of averages, let's look at the sets. And so I'm going to use that same format in the table and put in driver scores to kind of just start thinking through. So let's see. I might do this a few times to kind of just keep thinking through this. So let's say 3 rides per service per state. So Washington, let's give it 2 5s and a 4. Lyft, let's give a 5 and 2 4s. In Oregon, let's say that the drivers got 5s across the board, so that's 3 5s. And then for Lyft, let's do 2 5s and a 4. Okay. I love doing it this way because it's really easy for me to just look at the numbers and quickly understand by seeing, okay, this doesn't work because the Uber average is higher than the Lyft average. So let me try and rebalancing the drivers so it's not 3 per state per service, but let's make it in this case so that more people are taking Uber rides than Lyft rides. So I'm going to take some of these numbers and I'm just going to write them out again. So Uber, let's see. Let's just take one of the Lyft rides, the one that was a 5, and let's give it to Uber. So we have 5, 5, 5, 4, and then Lyft has 4, 4. And then in Oregon, in Oregon, we have a 5 rating and the rest are 4 ratings. And then for Lyft, we have, just a handful of 4s. So then when we're looking at these combined, we see that the average for Uber is greater than 4 and the average for Lyft is equal to 4. This isn't the solution yet, but what I'm noticing when this is unbalanced is a service can win in a state even if there are very, very few rides. So if you have a single 5-star driver, 5-star ride that's in a state, then it wins over a service that has a whole bunch of 5s and a single 4, bringing down that score. And so conversely, you can lose if you have a single 4-star driver in a state which has a whole lot of 5s. And so just kind of trying to keep that in mind. I think I have this nailed, and I'm just going to make sure that I write out the numbers correctly before sharing. All right, so I'm going to read you the answer that I have. So in Washington, in this particular example, we have 5 Uber rides that are, or 5 Uber drivers that are 5, 5, 4, 4, 4. And we have a Lyft rating that's 4. In Oregon, we have an Uber rating that's 5. And we have Lyft ratings that are 4, 5, 5, 5, 5. And so from this, we can see that it fits the terms of the original problem posed. And so we see that Uber's winning score in Washington is lower than Lyft's losing score in Oregon. And so because most Uber drivers are in Washington and most Lyft drivers are in Oregon, then Uber's average gets pulled toward its lower score, its lower Washington score, and Lyft's average gets pulled toward its higher Oregon score. And so I think that's the explanation for the original quirk that we noticed. Just kind of thinking back, to taking statistics, I remember learning about something called Simpson's paradox. And so what we learned it as related to batting averages, since that's a pretty common way of learning statistics, it would be something like Jose has a higher batting average than Tim in both the first and the second halves of the season, but Tim has a higher batting average overall. And so it's a pretty similar sort of question to our ride sharing question. And that same sort of gotcha applies, which is why it makes it such a fun brain teaser. I think the cool lesson about it to me is just that averages can be really misleading if we look at those without understanding the actual data that comprises that average.
Perfect. Thanks for walking me through that. I think you definitely got the answer, and that takeaway is really important. Thank you. So this is a really tricky question. At first, it's really hard to piece together why this is happening. Why are Uber's ratings on average higher in Washington State and Oregon State, but then the flip happens when you add all of that data together? It's something that doesn't intuitively make sense. And so when you get a question like this, do exactly what Sabrina did. Break down this question rather than it just being a theoretical question, add numbers. And when she added numbers in the first step, she realized that by just having averages, it wasn't easy to understand. So she wrote down the exact set for what these numbers might look like in each of these locations for Uber and Lyft. And then she noticed a pattern, and she did it again. And she noticed another pattern, and then she finally got to the answer. And so rather than getting stuck and just thinking about it and thinking about it and taking 10 to 15 minutes and not getting to the answer, you're now showing your interviewer that you can take this hard problem, break it down, and step by step get closer and closer and closer until you get to the final answer. And so do exactly that. Write out, take this theoretical approach, then make it practical, write down the numbers, break down the numbers, try a few cases, and then get to the answer. And at the end, she mentioned an example of a thing that she had learned in statistics class in college that she tied back to this example, and she made it more relatable. And so any nuggets like that you can do at the end of some abstract brain teaser type question like this to tie it back to a real world scenario makes the interviewer understand that this is not just a lucky occurrence that you were able to get to this. You are able to see the bigger picture view and tie it back to an example to get the higher, bigger picture message, which in this case was that you can't trust averages because they mask what underlying data is underneath them.
With our courses, you will go from being a candidate to being the candidate. Sign up below to attend a PM interview webinar where we mock interview an expert PM from Google to show you what 10 out of 10 interview responses look like.